Welcome to What Do Engineers Do by students at Brigham Young University, created by the BYU LIFE Club, where we interview real engineers and learn about their experiences, stories, and advice for those who are wanting to become engineers. Welcome to another episode of What Do Engineers Do? My name is Bryce Haslam, and my co-host today is Sam Christensen.
Hello.
And today we are excited to have Kent Layton from the company Triad Semiconductor with us on the podcast today.
Hey guys.
And we're very excited to have him. His just a little bit of a brief background about Kent. He got his undergraduate degree in electrical engineering from Brigham Young University, along with his master's and PhD in electrical engineering from Brigham Young University. His current employment is a principal IC design engineer at Triad Semiconductor. And a couple of awards of note for him. He has experience as a system architect, a project lead, an analog design lead over many ASICs, and he is on 10 US patents. And Ken, it's great to have you here today. Thanks for taking your time out of your busy schedule to be here today with us. And we're very happy to have you here.
Yeah, my pleasure. Thanks for having me.
Yeah. And so we're really excited to talk to you today and learn more about what you did to become an engineer, along with what you do as an engineer in your day-to-day routine. So to start, we just wanted to start with a couple questions about a little bit of your background. So first off, what were your first experiences with engineering?
Um, I think the experience that is the first one I remember. I when I was younger, there was a clock that we had, an analog, with hands, and it had a little electric motor. And for some reason, I decided it should be taken apart. So I took it apart, and I couldn't really understand what was going on inside, so I put it back together. And when I turned it back on, or plugged it back in, it ran backwards. So my family thought I did that on purpose. I really still have no idea what was going on, but everything in there intrigued me, and I thought, yeah, I was hooked.
I love
Keep
it.
wanting to open things up.
Yeah, I love it. That's a great way to get hooked into engineering, taking things apart. I love it. And
Totally.
we, Sam?
Yeah, no, I completely agree. I think that that's honestly just how a lot of engineers that I know got their start, right? Is they're like, ah, let's just take it apart. So very cool.
Yeah, exactly. And Ken, could you tell us a little bit about your early educational background, possibly even before college?
Um, if you're wondering if I graduated from high school, I did. I know that question comes up a lot. No, um, no, I always enjoyed math, and so yeah, I took whatever math I could from early on, and then in high school I took physics and loved it. So I did like the AP physics and pretty much anything on the math and science side of things. I took whatever was available to me.
Yeah, I love it. Physics is a tough class. So,
It is, yeah, but I love it. And I will tell anyone that.
I love it. Thank you. And going along with that, how did you choose your major?
Uh, so, and this may not be the answer you want to hear. I originally loved programming computers as well. So I was kind of self-taught in high school. I won't tell you how old I am, but it was a time when there weren't there weren't that many educational opportunities in high school to learn computers anyway. So I was kind of self-taught and wanted to do that when I went into college. So I actually I had declared that as a major, but then my dad, knowing how much I liked math and physics, said, you should really try engineering. So I declared both computer science and electrical engineering as majors. And after my first computer science class, I dropped the computer science part of it and went
Mhm.
completely in engineering.
Nice. Yeah, I love
That
it.
yeah, that's relatable. I think a lot of a lot of students start out thinking they're going to do something else, right? Um, like personally, I started out thinking I was going to be a chemical engineer, and then I realized I really don't love this. And so, yeah, I think that's really true that, even if you don't start out in engineering, you can find your way there.
Yeah.
Exactly. And that is why we're here in college, is to figure out what we want to do. And so that oftentimes is how it will go. We will bounce through majors until we find what is right. Um, and going along with that, what was your first major project that you decided to work on?
Oh, you mean associated with school or even or prior to that or
It can be both.
I'm boy, now we're gonna stretch the limits of my memory here. Um, so I'll jump to something in school, in college. So there, as part of the engineering classes, you often have labs, and there were a handful of those, along the way. But probably around my junior year, I was able to start working in one of the research labs in the department. And as part of that, I was tasked with um, just making some design changes to an integrated op amp. So I think my professor wanted me to um, increase the bandwidth, double the bandwidth. And at the time, I probably should have known better what I was doing than I really did.
Mhm.
But one thing that I learned is even if you've had the classes that teach you the math, there's still quite a bit to learn to be able to apply that to a real world situation and have it work. Uh, you know, I was once going over a journal that I had at the time, and I had made comments about this project, and I remember looking at what what was going through my head in my journal, and I was like, yeah, I still had a lot to learn at that time, but it was good. It was a good growing experience for me.
Yeah.
Yeah, and for those listening who may not know, what is an op amp or an operational amplifier?
Oh, so it's an electrical circuit that takes the difference between two input voltages and uh, multiplies that difference and puts the output as a voltage, or that takes that result multiplied up on the output. And so those can be configured in a lot of different ways uh, to um, to evaluate signals and to uh, precondition signals for other uses.
Awesome. Thank
Cool.
you for explaining that. Yeah. And kind of along those lines, we know that as engineers, to be able to get internships and also to be able to get a job, you need to be able to have a little bit of a background. So, do you have maybe a project you remember outside of college or outside of school that you did?
So as far well with electrical engineering, until I started getting into the research lab, I didn't do a lot of electrical projects.
Mhm.
Um, I did a lot with programming, as I had mentioned before. I had designed programs that you could like plot, you could identify 3D points, and it would like draw those shapes and allow you to manipulate and move them around. So that was always a fun one. I Yeah, that was a fun one. Um, uh, well, I actually used some computer programs to ask girls out on dates a couple times. So um,
Ooh.
maybe that's telling a little too much as as an engineer. Maybe I should have worked on other social skills. But anyway,
That's impressive. No, I love it. That's awesome. And it is interesting because it is a very different experience for everyone. The projects that we'll maybe do, how we get the internships. And so going with that, Can you tell me about any internship or maybe your first internship that you had?
So the first internship that I had was for a mechanical engineering company, and it turns out it had nothing to do with my background in school or engineering. It was they were it was for a company based out of Japan, and I happened to serve a mission in Japan, and so I had a bit of at least engineering understanding, and I had some language skills, and that so that's how I started out there. After that, though, the internships I was able to get were through the research lab that I worked for. So I ended up doing some work for a company that manufactures ICs up in Idaho, and but again through the research lab on campus.
Amazing. Yeah, that's awesome. And I loved how you pulled in also that there's other aspects of your life that actually helped with engineering. For example, your mission that you served for the Church of Jesus Christ of Latter-day Saints. You learned Japanese, became accustomed with the Japanese people, and so that helped you. And
Yeah.
so that's really interesting. I love to hear that.
I do have a question. How did you survive a mechanical engineering internship if you were an electrical engineer?
So I wasn't far into the electrical engineering program at that time, and most of what they had me do was actually computer related and a lot of document related things. So and I should step back. I think honestly, if I had decided to go into mechanical engineering, I bet there are aspects I would have really enjoyed there as well. So I don't know. I think engineering, while there are different types of engineering, I think there's a mindset to it where you just enjoy understanding how things work and want to figure out new ways to do things or better ways to do things. Yeah, I probably could have been very happy with mechanical, but I completely love electrical engineering.
That's amazing. Yeah. And kind of going along with that, you chose to get a master's and a PhD in electrical engineering. And what was the reasoning behind getting a master's and a PhD for you? What was your thinking for that?
So for the field that I wanted to go into, which was analog IC design, it can be difficult to yeah to get started with a bachelor's degree. Um, there's a pretty steep learning curve, and getting a master's just gives you a pretty good step up on kind of breaking in and getting started in that field. So that was probably the main thing. At the time, BYU had a program that was called an integrated master's, and so you could do the coursework for your master's degree while you were doing your undergraduate coursework as well. And then it allowed you to just do a thesis, a master's thesis, and that would cover your senior project. So I probably shouldn't be saying this because everyone's going to say that's no fair. So I apologize to all those who can't take advantage of that. But that was a really convenient way to work all the way through a master's degree.
Yeah, that's very interesting. Yeah.
And what did you research for your PhD?
So it was in analog integrated circuits. I can't even remember what the title was, but I was researching the minimum supply voltage that you could design analog circuits in, and well, while still maintaining strong inversion on the transistors.
Nice.
Super
Awesome.
cool.
That is amazing. Yeah. And kind of with all of this, all that we've talked about here, were there any major challenges that you had? It can be anywhere in the span that we've talked about in these times of your life. What was maybe some of the major challenges you had?
Well, so I'll give my well my perspective on, for example, just working through getting a degree. So in electrical engineering, and I would assume other engineering disciplines as well, There's a lot to learn, and and you try to move through it pretty quickly. So especially like the junior core classes can be pretty challenging. There's a lot of information that you're trying to learn in a short amount of time, and you know it, it's just hard. And so anyway, uh, I think that was probably the hardest part of all of my schooling, was just kind of getting through that junior core. And then I found that after that, everything just seemed a lot easier. Like, and I don't know if it's because they made us so strong by working us so hard at that level, but you get to the senior level classes, and I thought they were really interesting, and the more interesting it is to you, usually the quicker you pick it up, and the better you do. And then graduate level classes were more of the same. They were all really interesting, and in my mind easier than some of those first ones. So I guess I say part of that to encourage anyone out there who's at that level, when they're taking these classes and struggling, that you can make it, and it gets better. Like it gets more and more enjoyable. The
There
one
is
other thing
hope.
I'll add. Oh, sorry, go ahead.
Oh, I just said there is hope.
Yes, there is hope. And the other thing I was going to say is, probably one of the other hard things was, while I was working on my PhD. Um, it was the professors that I was working with didn't necessarily have any specific research for me to work on. So it was up to me to come up with a topic and to do the research kind of on my own. So I was kind of on my own for that. And so it took a while to come up with um, a topic and some research that my professors were comfortable with. Um, and yeah, so it was difficult to really get going on that research. But then once I did, it was a lot of fun. It was good.
Yeah. Thank you for sharing that. Yeah, that's amazing. What doesn't kill you makes you stronger. So I love
Indeed.
I love to hear it. And what advice would you give to people when it comes to moving forward in for example, like going into internships or going for interviewing a job or just taking kind of these steps in life? Do you have any advice?
Um, so I think it's you know, usually the hardest thing is getting your foot in the door. And and I don't know if I have much advice for getting your foot in the door, other than to say, uh, take whatever opportunities arise. And so the first opportunity you get may not be the one you're expecting, or the ideal one in your mind. But you can learn a lot by working with others who are in the industry. Um, and then if you just really put the effort uh, into learning anything that is interesting to you. Um, and sometimes that may not be your primary job function, but anytime that you put forth effort and can show that you're able to grow and learn, you'll be given more opportunities to work in that area. So if there's something you really enjoy, keep at it, and show those around you that you have a passion for it, and you'll have more opportunities.
Thank you. That is some great advice. Yeah. And so kind of continuing on now, we would like to know a little bit more about what you do as an engineer now. What is kind of like your life now? And so first I would like to ask, why did you choose the company that you're currently at?
Okay, so I uh, I'm gonna have to back up before I can, as part of that explanation.
Yeah.
Uh, I uh, worked for a company right out of graduation, doing analog circuit design, which was exactly what I wanted to do. It had some ties with the research lab that I had worked at BYU, and I uh, essentially worked for at the same company. There were some changes in ownership and that sort of thing, but I worked there for over 20 years, doing analog circuit design, and there are a lot of different aspects to that, and that job allowed me um, to learn about a lot of different applications and a lot of different systems and circuits, for the various applications.
Hmm.
So anyway, I really enjoyed that until the day that company decided they were going to close the office that was near where I live. So I had the option of finding another job or moving to another state.
Hmm.
Um, but anyway, so wanting to stay where I was, I found Triad Semiconductor, who I work for now, and it turns out they do many of the same things that I did before. So, I mean, I don't want it to sound like I'm not up for venturing out and doing new things, but I enjoy it so much. I just wanted to keep doing it. So,
Yeah.
so that's why I decided to start work for them. So, again, I get to design analog circuits for many different applications, and uh, it's just really fun to see all the places you know that we have ICs that can improve systems, add efficiencies, and that sort of thing.
I I'm interested to know. Um, I've heard that some people really like to, find one spot and stick with it, and other engineers will like to kind of hop around companies with some regularity. Um, can you have you met those kinds of engineers, or is that mostly just a misnomer or a misunderstanding of what engineers normally do?
No, yeah, there certainly are. Um, yeah, both types. I have met people who would change jobs every 3 or 4 years. Um, yeah, a lot of times that happens. So for what I do with integrated circuit design, it's part of the semiconductor industry, and the semiconductor industry is really well known for having a really cyclic um, behavior to it, meaning there are times when everything is going great, and people can't find enough engineers to do the work, and then a year later, um, there are a lot of engineers out of work. So, and it varies by industry a bit as well. I was lucky enough to be at a company originally where they the many of the projects were really long. It would take several years to work through a project, and so there was some stability there in that you get the when the cycle is 2 years and your project is 2 years, well, you just stayed in this. You did the same thing while during the peak and the valley.
Yeah.
But anyway, so some engineers, by out of necessity, if things are going uh, well, you have a job and then you get laid off and you have to find something else. So sometimes it's out of necessity that you might jump from job to job. During the peak times, though, you may also find that you can make a lot of money by signing bonuses by by changing jobs. So uh, it varies from person to person. Um, I enjoyed staying where I was for a long time, and I've been where I am for about 3 years now, and it's again, as long as I get to work on cool circuits, I usually forget about everything else that's going on.
Yeah. I love it. Thank you so much. And what is your job like on a day-to-day basis? Like what is your daily routine as an engineer like?
So it's not really well defined. So for me, I have circuits with given parameters that I need to design, and so um, it's using computer-aided design programs, so CAD programs to draw up circuits and to run simulations on circuits and prove whether or not they meet certain parameters. And then there are obviously meetings. I mean, those are probably the only things uh, that are defined for specific times. But Um, I probably average a couple of hours of meetings, whether it's reviewing other people's circuits or discussing the requirements for an overall chip, to make sure that all of our individual circuits are working together as expected.
Mm.
And then, you know, if it's a good day, I get to spend all day designing. But I probably get 2 hours of meetings, and the rest of my day I can usually go do the things that I enjoy. Um, yeah, and then when we get silicon back and we actually have circuits in hand, I then I would spend a fair amount of time actually uh, with equipment trying to measure the performance of the circuits as well.
Interesting. Yeah, thank you. Thank you for sharing that. It's really interesting to see how it varies from engineer to engineer and from person to person. And what classes did you take in college that maybe you feel like helped you the most in this job?
So for me, it would have been probably the first, well, the first class that really started to give experience with CMOS, various CMOS circuits. I think it was 445. I think it's a mixed signal VLSI class, if I recall correctly. And then from there are a handful of graduate level classes, maybe five. I, I, the numbers may have changed. So there's a class on CMOS amplifiers that was really good. Um, I actually currently I teach a class or a course once a year at BYU right now, and so that's 551, which is Introduction to Digital VLSI Circuits, which I guess I'm biased, but I think it's got a lot of good information on that one.
Yeah.
So for me, it was all of the analog circuits classes that really helped me out uh, in what I do now.
Nice. Yeah. And then
So you've mentioned analog circuitry and like analog design quite a bit. Um, for people who may not be familiar, um, what's the difference between digital and analog design?
So analog design deals with I'm going to say the real world. Maybe I'm a little biased, but as you look around yourself, you're not seeing ones and zeros, which is what digital is. So digital is really good at for computing things, for things that need to be very repeatable, and it has, anyways, it derives a lot of our technology today. But for every digital circuit, anytime that you have to interface with that, there needs to be an analog component to it. So like a camera, the image sensors on a for a camera would be analog. Um, the microphone that you're speaking into in order to talk on your phone, that's analog. I worked on some chips that went in, and this is maybe a little bit dated. All of you used to swipe your credit card with that magnetic strip. Um, we did the circuits that went in 95% of all the credit card readers, um, you know, in the world. So all of those things, anything that we interact with is analog. So sound, sight, and and temperature. So a temperature sensor. I'm trying to think. Um, yeah, any of those things. If we want to get it into the digital world to manipulate it, we need some analog circuits to get it there.
yeah.
Okay. So you're doing a lot of like analog transformations, or you have incoming voltages and you're doing operations and various, integrated circuitry to then transform that into something that a computer could read.
Yeah, yeah. So typically, yeah, some sort of sensor interface, whether it's for sight or sound or temperature or um, yeah, anything that interacts with the world around you. And then we often have a circuit that's called an analog to digital converter. And so that will take it and it'll say, okay, within an expected range of what this sensor could output, the value is currently here, and now it's moving, and now you've got a sine wave. And anyway, and then we pass that on to the digital, and the digital can analyze it in whatever way makes sense for the system to deal with that information.
Yeah. Thank you for that
And then I
explanation.
guess I should add on the back end, once the digital is done with it, for example, to even see it on your computer screen, it works its way back to the analog world. So there are digital to analog converters, and so we bring that information back and allow it to be presented back to humans, to us.
Yeah. Thank you for that explanation. That makes a lot more sense to maybe those who are listening. And just, it was amazing to get to learn about what you do as an engineer, Kent. Um,
Thanks.
we thank you so much for the time that you've given us. I know I've learned a lot. I hope that the people listening have learned a lot as well about what do engineers do. And this has definitely been a very intriguing and learning experience for all of us. So we thank you for your time and participation.
Thank you. It's
Yeah,
been fun, and I just stick with it. That's all I'll say. I love engineering. You will too if you stick with it.
yeah. Thank you so much, Kent. And for everyone listening, our guest today has been Kent Layton from Triad Semiconductor. And thanks for joining us. We appreciate your time, and this has been a lot of fun. But we'll see you guys next time, hopefully.
Thanks, everyone.
Thanks so much.
You have been listening to What Do Engineers Do? You can find more podcasts on Podbean, Apple, and Spotify. And we hope that you tune in next time.